So here's a geometrical look at some vectors. First of all, add them together. So to add two vectors, you just add the first component with the first component and the second component with the second component. So u plus v is going to be a 2 combined with a -3 is -1, and then a 7 and 4 is 11. Now, if you take a look at the graph, the original graph was, let's go over to 2 and up to 7. There's the vector u. And then -3, 4 would be this vector. And then -1, 11 would be somewhere up here. So I was able to add these vectors algebraically and then just graph it and find out when you add two vectors, the result is actually in between the two. Another thing you can do is vectors can be moved around. So this vector right here, now this is more of a geometric way to look at it rather than algebraic, but this vector, it points in a certain direction and it has a certain length, but other than that I can pick it up and move it over. So just make one that's parallel to this, and that would be this. And likewise here, make one that's parallel to this, and what it makes is a parallelogram. And when you add the two vectors together, what you're getting is the diagonal of the parallelogram. And then what about subtracting the two? So for part B, u minus v is going to be, so u subtract this is going to make it a +3, together with 2 makes 5, and then 7 minus 4 is 3, and so graph that. So again, to compare, for comparison's sake, I'm going to put the original vectors 2, 7, so there's the vector u, and then the vector v, -3 and 4 would be over here, and then when you subtract them, it's a 5, 3, so that would be over here. Well, how does that vector compare to the originals? If you take this vector, and again you can just pick it up and move it, it would be going right across here. So if you have two vectors u and v, then make a parallelogram out of that, and when you add them together, that's going to be the diagonal of the parallelogram. And if you have two vectors u and v and you subtract them, then that would be the same as laying a vector across the top like this, and that's u minus v. And then v minus u would go the other direction. And then the final part is part C. What about 2 times vector v? Well, that means take these and double them. So -3 gets doubled, becomes a -6. The 4 gets doubled, it's an 8. And so the original vector was -3 and 4. There's the original vector v. And then double it, so it's -6 and 8. Well, -6, 8 then would take it out here. So it basically says take that vector and just double it. So it's going to go the same direction but be twice